Hold on here. Let me show you what it is that we're going to be doing today.
Alright, let's get that.
So, if we go to the live hack that we're viewing, do you see this clip? This was from a video I did in the wintertime. What I had done is I was programming the robot to move in different positions and program the auto positioner with the Wii controllers. But what we're going to talk about today is the virtual reality, because I was controlling, as you can see, the head with my head. So here's my VR headset that we're going to use. If we have time, I can also turn on the Android version as well that you can use Google Cardboard with. So this is the, I think it's made by Samsung. And it's the, yeah, there it is, made by Samsung. And this is the Windows Mixed Reality from Samsung. And it's good. I think it's the best one you can get for the price, specifically because it actually has speakers. All the other ones that they have for Windows Mixed Reality, at least most of them, like the Dell and things like that, they don't actually have speakers inside of them. So this one's good. We also have Oculus Rift and we have HTC Vive, but HTC Vive's a pain in the butt to set up because you have to put up these sensors and all this kind of stuff. This one you don't need to. It uses kind of like what the HoloLens uses. It uses the cameras so it can see and track. Wow, my laptop's got a lot of stuff plugged into it. There you go. I'm gonna be able to take all this. Let's load up Easy Builder and make sure that we have all the plugins and everything that we need installed to start what we're gonna do. Let's close this. Let's take a look. So, project, add, get plugins, and the plugin that we want is going to be under virtual reality and virtual reality robot. This is the one. And then click install. And it'll download it. So this is 17 megs it looks like. And then click on it. And it'll install. Ooh, it's a big install. There we go. And now we can go project, add. And we want a robot camera, so we're going to get one of those. Okay. And then we want some virtual reality here. Virtual reality. Clickety click. There it is. Okay. So, I think the easiest thing for us just to demo is to get just use the camera on my laptop. So let's just use integrated camera. And then we'll have to specify a resolution because I know this laptop doesn't like anything other than like 720 by, is it 1280? Is that right? Nope. What's the resolution for 720, Jay? Is it 1280 by 720? That sounds right. No, that's not right either. Let's take a look on the internet. Will, you should be able to speak up on this one. 1280 by 720. That's what I put in. 1280 by 720. Well, unless the laptop is being, or the, oh, there we go. Camera's working. Perfect. Okay, so this will we're just adding a camera just so that we can view something inside the VR headset, but we don't actually have it hooked up to a robot, right? It's just hooked up to the inside of this. So let's start by clicking. So on the app here, you can see there's a Start VR client. Because we're not running a Google Chrome, Google Cardboard or anything else, if we were like running it on our phone, we wouldn't start the VR client because the VR client would be on the device. So we can click the configuration button here and you can see that we have different options: pause servos when robot is moving, launch VR, and full client. So we're not going to do that. We're not going to add any servos. We're just going to click attached camera. So it's attached, because it says so. It says attached, detach, and then we'll click this Start VR client.
It's kind of inverted, so my left
And now we wait, and it's going to load it and connect to the headset. So just give it a second. There it is. Okay, so this is the VR client here. Oh, you guys can't see it. Oh, yeah, you can. Good. Because we're doing so much right now, my computer is not super happy with everything that's going on. So if it's a little choppy and slow for you, I apologize. Okay, so you'll see in this box that there's a, so I'm going to make it bigger for you. There you go. You can see in the box there's an IP address. That's going to be the IP address of your local computer. And 127.0.0.1, that's always your local host. If you were running this particular program on like a computer that was someplace else or over the internet, you could type in that IP address. Okay, so you'd actually be able to use this over the internet if you wanted, just by typing a different IP address in here. So we'll push the robot view button. And now, when I put the headset on, something you guys can't see is will be the view of the camera. And then what I could do is I can, there we go, you can see it's a little slow. So that's what I see inside the headset right now when I go like this. Okay. You can see that Steam VR is running and it's got it. Now I can adjust these values with the mouse. This is the depth and this is the brightness. You're going to probably want to play with these based upon your condition of lighting conditions. But your depth is interesting for your eyes because you might get like a lot of, I don't know, it's like this peripheral vision around. Okay. So you can't see the whole image on here, but I can when I wear the headset. So as you can see right now, what's coming through. I wonder what would happen if I actually turned the camera on close up and put this up like this. Can you see what's inside?
Getting a low on the amount of lick we have, so we just pull some more out. I kinda
Not really, eh?
My wick to have a
You just.
hole in it there.
Oh yeah. That's what you see inside the headset. That's cool. Okay, now you see we move the headset around. The image isn't moving, right? Now, if I were to back out of this, hit the back button, and now click on Cube View, now you can see what I would be seeing in the headset. Oh, this is so cool. Okay, so I'm looking around, I'm looking at this cube. Right? You see that, Jer? That's awesome. Cool. Okay. So this is so wild. Okay, so what we're going to do now is let's set it up so that it's using one of the cameras on a robot. Okay, so we can close all this down. We can detach. We can click this Close VR Client button here, which will close the VR client, obviously. And then we can click the Detach button from the camera. And I will entirely close down this. Cool. Okay, so I guess the next thing to do is get the robot in Move set up. So this is what we're going to use. Let's take a look here. Okay, so that's the robot we're going to play with today. I need to give it some power and also find a project. We should see if we actually have a project before we get too far. Oops. So I think I have one. I don't know if I have one locally. Let's find out. File system. Let's look inside of my drive. InMove. Okay, here we go. Oh, InMove remote control by Kinect, and then we have another project just called InMove. Okay, that's good news. So the one that's remote control, this one here, let's open it up and take a look. So I think that's the one we used with the Kinect and the Bioloid. That was a fun day. Okay, so we wouldn't have the Kinect running, so we would remove that. And these are Wii remotes. So let's keep these for the time being because they're already pre-configured for the Wiimote. If you want to see how I configured these, I would suggest you check out the live hack that I had done. I'll put a link to it in the description. And then this is the Dynamaxle control. We're not going to be using Dynamaxle servos. We're going to be using the InMove. And this here is the auto positioner for the InMove. Let's take a look and see how it's configured. Okay, there we go. It looks like all the ports are all configured as well. Super. Let's take a look at this one. So this auto position here, I imagine is, oh yeah, this one's for the InMove. Or not the InMove, this one is for the Bioloid. So we don't need this InMove or this auto position because we're not going to be using the Bioloid. Okay, there we go. Those are the two controls we need. So let's smart arrange these. Okay, there we go. And now let's connect to it over Easy Builder. So let's go to our desktop here. And I don't know, there's a lot of Easy Bs inside this office, so I'm not sure which one I'm connected to. Let's find out.
I think there's one in your office that's on.
Yeah, there is one in my office. It's been on for like a week. Okay. My battery is low. I don't know if you can hear that, but the battery alarm's going off. So we're going to turn that off. Click on the gear, settings, and we'll just turn off the battery monitor here. There we go. And just make sure this is set up for the right. Yep, it works. Let's check out these controls and make sure that they're configured correctly. Okay, if you look at this, these boards are already configured. Servos are configured for board index 1. I believe when we ran this test before, we were using index number 1. So maybe that's what we'll do. Let's let's disconnect, and let's use index number 1 because, oh, it has an IP address already.
So I can see the live chat.
Because I was thinking later we might connect to this robot and control it using a JD that I've hacked to read servo positions. I think that would be really neat. So that has to happen on board number 0. So these are configured now correctly. However, the auto positioner, if we look at the frames, the port index, you're going to see they're all on 0. What I'm going to do is I'm going to click on each one of these, and from the top here select 1. Because we're using the second EZB. And we're only doing that because we're going to eventually connect the JD at the same time and control the robot with JD. I think that's going to be fun. So you can see here it's saying 1.23 or 1.22. That's telling you what board index we're connected to. Because you can have up to 200 and something robots connected at once. So we'll change all these.
I think someone was asking about that a while back, a customer, about how many we can connect at once.
Well, if the customer was asking how many you can connect at once, if they didn't find a limit, then that's how many.
It's 256, I believe.
feel pure pressure to drink beer. You know what? Hey, if running a robot company doesn't work out for me, I can at least maybe be like Tom Cruise and Cocktail, serving beer to people and drinks and cocktails to Will. Okay, so the virtual ports, we'll change these ones as well. Oh, darn it, I did it again.
Oops.
V0, V1, V4. This was V5. I will change these ones as well. We're not using the fingers anyway. I think I have this thing turned off entirely. Oops. So this doesn't actually matter.
UCC to VM on this board down here.
Beer pressure.
Peer pressure.
I think beer pressure is only funny because I've been drinking beer. Alright, let's look. Almost done. It's the last one. There we go. Okay, so now everything on the auto positioner is set up for this. That's good. Let's save our project so that we don't lose it. We'll call it InMove VR. That sounds cool. Okay, so let's make sure some of these work. I'll click execute on the belly laugh. I'll make it so you guys can see it.
Okay. We got our power going, so let's test that out. The LED should come on this board up here. Yeah, right down here. That should turn on.
Cool. So that works. Let's go back to our desktop. Okay, so next all we have to do is add a camera.
Let's just stick to this one.
And I hope there's a camera in that robot.
Yeah, there should be one in the eye.
But is the camera not, is it hooked up to the EZB?
Yeah.
It's not.
It's not?
No, because we replaced it.
Oh, yeah. We're using the USB
The
camera?
USB camera.
Oh, yeah. You're right.
What do you think? Okay, so because we have a computer in the InMove, we actually put a USB camera in there. We don't have a camera to connect to the EZB. So I'm just gonna hot glue onto the side of his head like a cyborg from Star Trek. Because Star Trek's cool. Star Wars is not. Okay.
No, you got it wrong.
Hey, hold on. I'm gonna see if I can find a camera to use. I might have to steal one from Jeremy. Do you have a camera?
Yeah.
And a cable? How long of a cable? Do we have a wire cable in this?
In the back there's extended cables.
I don't have a code.
Oh, yeah. I'll get it for you then. BRB.
Can I take this off him?
What's this bucket doing out here?
I was in here.
Okay, we're going to move into from F-Zero. F-Zero, that reminds me of a certain game that I used to play.
Okay, cool. So now we have a camera on the robot, so we should be able to connect to it. Let's find out if that is true. There it is. Nice. So Jeremy gave me an extension cable. So there's a camera hooked up to the side of the head of the robot with some hot glue. So I'll just spray some alcohol on it later. Some booze. Spray some of the Will's Gentleman drinks. My name is Huff. Will Huff. Shaken, not stirred.
Nice.
What's the name of your sex tape?
Oh.
Okay.
Sure, there's one called the...
So, there's a sex tape called Will Huff?
No, Shaken, not stirred.
Will says yes, there is. It's in his it's in his drawer. I don't want to see it, Will. Keep it to yourself.
Oh, man.
Okay, so I'm going to add the virtual reality control. And let's look at the configuration for the in-move here, because we need to know what his head is. So this is, of course, Richard Ryerson's awesome in-move. I did not make it myself. I cannot get credit for this in-move. I'm not that talented.
It's good to see Richard in the forum.
Yeah, Richard is in the forum.
Yeah.
Stirring up shit as always. Me and Richard. I love you, Richard.
Yeah. You're the best.
Okay, D22 and D23 are the servo servo settings. So let's take a look and see which one this does.
Alright.
Oh, it helps if I turn real-time update on.
So,
There we go.
next one is 23, okay.
Okay, so D22 is his left and right,
2,
and I'm taking it that D23 is his up and down. So 22 is left and right. So let's go into the virtual reality robot configuration. It will specify the vertical servo to be D23. And let's set up these parameters here. Oops. This one here. Oh, right, and it's also on board index number 1. There we go. Oh, D23. Let's look down. Okay, that's about as far as we can look down. There we go, without getting it caught, and let's look up. And that's about as far as we can look up. And then let's do the same with left and right. Board index number 1. And the other direction. So we just set up the max and minimum positions for what it would be like when you're actually looking through the robot. Now what we can do, here we'll just click the save button. And let's attach the camera.
4.
There we go. And now let's start the VR client. Okay, and we'll place our headset down. And then we'll push the robot view button. Wait for see it. Okay, there we go. Now we'll click activate servos. Alright, so now when I move the headset, you can see in the little window the robot's head moving back and forth, and I can look up and I can look down. So it looks like everything is configured correctly. So I will show you something. What I'll do is I'll grab the camera that's close up for you, and I'll place it inside of the robot again, or inside of the headset, sorry. Okay, so you're seeing right now what you'd be seeing through the robot view, and I can move back and forth, and up, and down. So you instantly become the robot. Here, I'll put it on and show you.
No, I don't think that's it.
Oh, this is so cool.
Let's continue to search.
That is so cool. So that's it. That's the whole thing, guys. You're viewing in VR. That's pretty neat. You know what's pretty cool is you would be able to connect to this remotely right now and actually control this entire thing in over the internet. If I had, I mean, right now it'd be a little difficult because I'd have to like get everything set up for the firewall and everything for you to connect off the internet. But yeah, you'd totally be able to do that. So now that I showed you how to do that, do you guys have any questions? Because I think it was pretty straightforward. Let me know if you have any questions. I'll just sip on a beer for a second. We can hook up the Wii controllers and control his arms if we wanted. Or, no, let's do the JD. Oh, yes. Cool. Okay. So we have the VR. It's cool. It works. You guys okay if we move on to a different hack that who suggested it? He's eager to get this set up. This works with the latest beta. Yep. Latest beta or the latest production, whatever. I'm using, as you can see here, the beta version. I have no idea what version I'm using. Oh, there's a bug in the beta version when you click about. 2019-05-08. That's the version I'm using right now. So install the plugin, push the configure button, configure your servos to be your max and min range. This is common across all controls in Easy Builder, right? And that's it. As you can see from my configuration, I had to invert direction. Will, so I'm not sure how your servos are placed. It matters if your servos are upside down or not, or the directions. Certain servos have different directions for some reason as well. So you might have to push those buttons. Other than that, that's all I had to do. Oh, do you guys want to see something really cool? Let's do another hack. Let's not use the InMove for a second. I want to control a massive... Oh no, I don't have the camera on the hexapod. We have this massive hexapod that we built, and it's huge. I'll show you the size of it, but the camera's not hooked up yet. We still have a few more parts to 3D print. Let me go grab it. Yeah, check out the size of this thing. Well, I gotta move some stuff around to make some room for it. It is massive. You get an idea how big this thing is. Like, here's a beer next to it. It's just huge. These servos are just crazy. They're big. They were like this orange color. I'll show you. This is the color they came, and I just painted them black and primered them with some etching primer. And then because these servos also, they run off 6 volt. They don't like 7 volts from a lithium polymer. So we designed this board. Well, Jeremy designed this board. I'll bring it down so you can see it. It connects to an EZB, and it's full of voltage regulators. So there's a voltage regulator per servo. Baboo, controlling the hands with the leap motion, you could do it. We don't have a leap motion control in our software because leap motion's out of business and they're hard to find, the devices. So there's no driver support anymore, and it's not that great. Instead, I recommend using like Wii controllers from Nintendo. Those are good. You can use. You can modify the plugin when it's open source to add HTC Vive controller to it. That would be pretty easy as well. Maybe we'll do that one day. But yeah, this hexapod is great. But the only problem is that this doesn't fit on yet. See, it's too high because inside there's a servo. So I mean, I guess what I could do is spray some booze in here and take that servo out. Here, I got some booze here. I'll spray it in. Spraying the booze. Spraying some cocktails. Will's gonna smell the booze, the cocktails, as we come running. Okay, we'll just take the servo out for time being. The idea with the servo is it's going to be inside the dome, and the magnet is holding this on. So if you look inside, so the camera would be able to move around by the magnet and turn left and right. Pretty neat, huh? So it's kind of like that BB-8, but so I got to figure out how to fit a servo in there with this controller at the same time. So let's start off. Let's turn this thing on. Yeah, just like that the BB-8 Star Wars droid, you're right. It's kind of tight here. So this goes here. And then this is neat too, the actual dome connects with magnets onto the body. So just, I'm not sure which way this is supposed to go yet, we'll find out. There it is, that way. Wild. Let's turn this thing on. Oh, first I have to get the project. Jeremy sent it to me in email. So let's check my email. You can't see that. I am checking my email. All right, Jeremy. Where's your email? Mega 6. There it is, Mega 6. It's thrown inside of my Easy Builder projects. Cool. Okay, so here's Mega 6. So we don't need this project anymore. Let's oops. Let me just double click on this. There we go. All right. Wi-Fi for this thing. Let's turn it on first. It's going to jump up too, so we probably want to put it on the floor. So let's connect to its Wi-Fi. I'm going to turn the in-move off while we do this. One sec. There we go. There's no need for it to be on while we're doing this. I can hear it humming away in the background. So does this thing have a name? I'm guessing it's... Must be this one here. We should give this thing a appropriate name so that we can connect to it next time. So let's go into its configuration settings here. And oops, that's not the configuration settings. This is. And let's configure the controller. Let's see, client mode, AP mode. There we go. Let's call it Mega 6. And sure, that's good enough. Yeah, there's too many robots in this office. Although there's nonsense. Who's ever said too many robots? Those words have never been spoken. Come on, Windows, you can do it. You can update the SSID. I know you can. I've seen you do it before. Oh, I saw it. Mega 6. Where'd you go? There you are. Okay, I'm going to put this guy on the floor because when we connect to it, he's going to go... Okay, here we go. 1, 2, 3. He moved a single servo. That's a sign. Whoa. Oh, I don't think he has a configuration to when he initializes. Let's find out, guys. Oh, there we go. Oh, there's a variable missing. Sleep $, but $, doesn't have a value. So $, will make it equal 500 milliseconds. Let's make it equal 1 second.
That's a 15 milliseconds. But it didn't save?
No.
Of deleting or something?
We'll make it 500 milliseconds. That's good. And then we'll save it. And then let's do it again so we can watch him initialize. So I'm going to turn him off. And then back on. I'm going to move all his servos into random places. There we go. Okay, let's try it again. Cool. I like that initialization. That's cool. All right. Oh, that's great. Super, super awesome. Let's make him do the dance. Boy, he's so big. I wouldn't want to see one of these things chasing after me at night.
Alright, we definitely need to use all of these. And go to have the PWM. I just want to read those values coming from the power glove.
That's so neat. Where are you going? Come back. Oh, one of the servos is stuck.
Yeah, there we go.
There's that one servo gets stuck every now and then. Okay, so I have an idea, guys. Here's what we're gonna do. we're going to configure this robot to be controlled by the headset, the virtual reality headset, so we can move it around. Okay? So this is going to be really neat. Let's go back here. Let's add to our project virtual reality, and we'll connect to the camera, and then we'll start the VR client because we're of course going to use that. There she is. Okay, now let's go into configuration. Okay, we're going to configure each servo individually, which means I'm going to go into one of these settings. Let's first make the robot look up and down. So to move up and down, I'm thinking we'll end up doing is we're going to move his front. Oops. We're going to move his front servos, these ones here, and his back servos. We're going to move those two to allow him to angle back and forth. So let's do vertical in the settings here. Now, I don't know. Oh, this is D0, D1. Okay, this is not set up yet. Looks like the configuration for this needs to be updated. So let's go into the robot designer. And I believe what's happened is these servos here this is D0. This is D1. Oh, you can't see what I'm seeing because of all this. Let me move this out of the way here. There we go. Okay. So this servo here is on D0, and this servo here is on D1, D0 and D1. And if we flip over to this one, counterclockwise, this is on D3 and D4. I think when Jeremy built this, he went D0, D1, D2, right, Jack? Okay, so this is actually going to be D2. And then this one will be D3. And then this one will be D4, D5, 6, 7, 8, 9. I feel like Sesame Street. 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Did you guys ever get that in the States? Or is that just a Canadian thing? 11! Okay, so now let's jump back into our virtual reality editor and the vertical servos. You'll see that these have been updated. And this makes more sense now. So, we want to control, like I mentioned, the front servo. So that was the 1 o'clock and the 11 o'clock. So these ones here. And we want to control the outside, because the outside servo is the ones that move up and down. So we want to control D1 and D3. So let's change this one to D1. And let's click Add. And we'll change this one to D3. And then now, let me put this, oops. Let me put, no, come back here. This one. Okay, so keep an eye on the little window up in the corner over here because you're going to see the servos move. I'm going to make these move down. So I'll zoom in so you can see what I'm doing. Okay, so when I go like this, that's making the servo move up, right? And this one, same thing. It's making the servo move down. Perfect. Hey, Amor. And then now we're going to do, it says we have to add other servos for the back. And those servos are going to be, it looks like, so 1 o'clock, 3 o'clock, so that's going to be 5 and 7. I don't think it, yeah, so 5 and 7. So that's D8, or D9 and D7. So let's add that. D9 and D7. D9 and D7. Hey Etrox, nice to see you, buddy. So let's move the same thing. These will move up rather than down because we want to force the robot to move up, right? So we can leave it at 90, that's going to be fine. And now let's have it do the opposite position, which is looking upwards. So looking upwards, 90, 90, and I'll move these back ones. Oh, so those ones have to be inverted. So we have to move this one. So I can show you what I'm doing when I do it in software. So I'm doing is I'm moving this one here to the same position. We'll go like 28. Okay, I'll make both of these 20. And then what I'm going to do is I'm going to click the invert button on this one because that's what it needs to look. There we go. So we can set these all to 30. 30 I think is a fine number for looking up and down. We'll make them equal. Cool. And we'll invert this one as well. Okay, so that means when we look up and down with our headset now, let's try it out. We should be able to have the robot looking up and down. So I'll grab the headset here. You can see it. And I'll click robot view. There it is. We'll click activate servos. Okay, so it's backwards because when I look up, the robot's looking down. So let's go back into our configuration here, into this, and let's, oops, wrong one, into the vertical. And let's lower these numbers down because it seemed like there was quite a bit of range, so we can get away with going down to 20. And now we're just going to reverse these inverted, right? Because it was when I looked up, I looked down. So these two need to be inverted, and these two do not need to be inverted. So let's save it, and let's go back into our activate servos. And you can see when I look up, the robot looks up. I look down, the robot looks down. Here, I'll make this full screen so you can see what I'm doing.
You can use one analog from over here, 22.
Okay, so to look up, that's so great. Very, very cool. Okay, so now let's do the left and right. So we'll detach from the servos and go back into configuration of the app, and our left and right will be something very similar. So now we're going to control these ones, the inside servos, because those are the ones that you can see that make the robot move left and right. Okay. So the inside ones here cause the robot to twist. So we're going to adjust all of those. This is going to be a lot easier than the up and down because all we're going to do is just cause those servos all to move. So we'll do inside servo D0, D2. We'll do it in order here. So we'll do D0, D2, D4, D6, D8, D10. So we'll select this one to D0. And D2. And D4. You can give these servos names, right? So we can find them again, but there's no point because we can see here what they are. So D4 and D6 and D8. And our final will be D10. And what we'll do is we'll move each one of these servo positions, minimum position.
CDJ for a little bit. Check out the.
So we'll move this the same to 30. And we'll move this one to the same thing. Looks like I can go even farther. We can make it go all the way to like 20. Let's do that.
Alright, so let's get back down here to our soldering section. Get this out of the way. Alright. Now, I should have did a bit more research before I.
Okay, so that's turning one direction. Now we want to set up the other direction. So we'll do the same thing. It's going to be a little crazy because all these servos are in the way. Why don't we
Double check my.
just save this and then make the robot go into that position and then go back into here. Oh, you can't see what I just did. What I did is I closed this down. I just hit stop. And then I went back into the editor so I can start editing the servos again because they were going to hit each other. So we want to move these ones up.
Different data sheet, I guess. This might have a different layout entirely.
Oh, I'm editing the wrong one. I was wondering what's going on with that robot. I clicked on this one. I'm supposed to be editing this one.
Yeah, just to show you.
Let's try this again.
I don't know if you can read it, but the top there it says part number and we're using PF1. So RF200 PF1.
So it looks like this one can move pretty far as well.
So that's.
Around 150.
Let's check the data sheet.
Perfect. So we can select 150 for all these guys. And so you can see what I'm doing too. I can right click on one of these controls and it pops, it does a drop down, which is convenient. There we go. We'll save these. Okay, let's see what happens when we use the headset now with our left and right. So let's try it out. So we'll click Activate Servos. And let's see what's happening. Okay, so it looks here that we're looking the wrong direction. Our left and right are reversed. So we know how to fix that. That's an easy one, right? We'll just go back into our editor and we'll edit this and we're just going to invert all of these. Okay, now that they're all inverted, he'll look the right direction. So let's check it out again. Ah, very cool. Okay, so now I can put the headset on and then I'll click in this window here so I can control the robot's movements. Oh, also I'm not going to want, so when I move right now, like if I say to make the robot move with this button here, when I try to move the headset, it's causing the robot to freak out. Oh, his battery's dying. One sec, guys.
No, it comes up with that error.
Cool. Okay, so we might get a little bit of juice left, so we'll keep playing with this guy and see what happens. Super cool. Okay, so we got to reconnect to the camera.
So it looks like we got 28.
And what we're going to do is, because the robot freaked out too, when we're trying to move, when you're looking around, it's the same legs that the robot uses to walk, right? So if we click on this gear here, there's an option here that says pause servos when the robot is moving in any direction. We want that checked. So let's also save this project as well. All right, so now let's go back into our robot view
Let's make a note of these.
and activate our servos, and we can look around. Okay, now when we cause the robot to actually start moving, it's not gonna freak out as much. So let me put the headset on. All right, so headset's on, and I need to find the button. There we go. So I'm gonna activate the servos, and now I can control it, and we can walk it around the office. Oh, this is so cool.
Analog 0.
Oh, this is so cool.
And 14, analog 1.
You guys gotta try this. This is amazing. Hold on, I'm gonna move the in move so you can see what I'm doing. That's better. Okay, here, check this out. So I can control the robot too with the arrow keys. So I'm watching what the robot sees. I can look around. So neat. I can look up. I can look down. And then I can move. And when I move, the headset's no longer doing anything. So there's the Neato vacuum that we're hacking for its LiDAR in our software that you'll see soon. Oh, we killed the battery again. It's right on the threshold.
My battery is low.
Alright, those are all the analog pins. Right?
Okay, let's back out of here and connect to it again.
7. For some reason I have an EC3, that's not right. Okay.
We're gonna drain the battery on this thing, but I can't help it. Like, this is one of the coolest things I've ever experienced. This is so awesome to actually be the robot. It is amazing. Let's connect back into it.
Okay. Pin
Okay.
20. We are connected
So
to
I'm,
one of the,
oops.
with one of the.
Let's see if we can make the robot go explore a little bit here.
Okay, cool. So that was our pin that was working.
Speed the robot up.
My battery is low.
Well, I think it's done now for a while.
My battery is low.
The dreaded sound.
My battery is low.
Oh no.
My battery is low. My battery is low.
Okay, we'll shut her down. So it will. I'm pretty sure it will chase you for draining the battery. It's probably going to chase me in my dreams. You have to finish Gargantia.
19, 18, 17.
Okay. Oh man, what a cool hack night. We're doing a lot of fun stuff tonight, guys. This is great. This is super cool. I have an idea. Let's use the headset to control one of our rover robots that we have here, and we can drive it around the office. Let's do that. Okay. So I'm going to put this robot back and grab a rolly rover. One sec.
So we have. With the accelerometer, we're doing 13. We have 13, 14, 15. Oh yeah, those are all those. So we have ADC 0, 1, 2. That's the accelerometer. So we'll have to look at our code. So that is to right. Perfect. We don't have to do any resoldering there. That's very cool. And then our fingers are 20, 19, 18. They're those guys. So 5, 6, 7 are the fingers. Alright, let's look back at our code for a second here. Zero, 1, 2, 5, 6, 7. I had them all there, but accelerometer is actually 0, 1, 2.
Okay, we got a new robot to play with. He's gonna be a lot of fun because we get to drive him around the office with the headset on. That's gonna be super cool. One sec, I'm losing my camera here.
5, 6, and 7. Now, I think what these pins mean, I'm actually probably not calling them correctly. So I'm reading ADC, but I'm reading ADC on these IO pins.
Okay, let's try this again without breaking stuff. All right, in our software, we save this project,
Show up, which is
and let's load.
and 5 and 6, which aren't actually tied to ADC.
Let's see, a Rolly project here. Easy Robot.
So
Rolly, where are you?
change that.
Rolly Bear. That's fine with me. Okay. Let's connect to it. Oop, I guess we have to connect to its Wi-Fi first. Did I turn it on? I did. Okay. What is your Wi-Fi, robot?
Actually, if it's ADC 0, that is actually 3.4.
Sweet. Okay, so now we need a camera for this robot. We'll add camera device. Connect to it. Sweet. Now we want to connect to, here, we can close these down, we don't need it. Asimo, I don't think Asimo jumped, did he? I think you're talking about like the Boston Dynamic robots.
Asimo jump, but like this high.
Yeah, if Asimo did jump, it wasn't very much, that's for sure. But you got to remember, like when you watch Boston Dynamics or the Honda Asimo, like a lot of that stuff, you're watching one successful take of 3 or 4 days worth of filming, right? Like they film for a week straight, and the robots just keep smashing and crashing and breaking, and then they eventually get one that works. So, yeah, the Asimo hop into one leg. That's just one big long program. I mean, you can make one. It's not that difficult. It's like we do that if you download our firmware for the balancing robot. That'll give you an idea of the Kalman filter and the PID loop you would need to run to be able to control the servos to make something not fall over. So that type of technology has been around for a long time. The challenge that I think the world's up against robotics isn't balancing and walking. It's more specifically performing tasks that are autonomous, not just pre-programmed. So a pre-programmed hop on one leg, not a big deal. But having the robot hop on one leg in any condition, that's a very big deal. Or even a bigger deal is have the robot decide why it should be hopping on one leg. That's opening up a whole new ball of wax of questions. But anyway, back onto our hack. Virtual reality. Let's add the virtual reality part. Okay, we're going to attach the camera. And then we're going to start the VR client here. And I'm going to drink some beer.
So let's connect.
And then I'm going to configure this thing. So looking back and forth, there's only one servo for that. And it should be listed here someplace. Here we go. Neck vertical, D9. That's easy. And now let's adjust its D9. So we can make it look up. Make it look up real high. That's cool. And make it look down.
Yeah, we're getting some good values here, I think.
Nice. We can make it look down pretty far too. And let's look at its left and right. What was that one? Neck horizontal, D10. And the other direction.
So some of those values aren't moving, but some are.
It's about good. And I'm thinking what's going to end up happening is, this is just a guess. I think that's going to need to be inverted. Let's find out. So I'll click on the robot view button here and wait for the image to load. And then we'll click on activate servos. And let's see. So up. Oops, up.
Except for that.
Oh no, up and down seem to be perfect. How about left and right? Okay, left and right seem to be reversed.
Does that value?
Okay, we'll jump back into here and let's change our left and right. Let's invert it. This button right here. And we also want to pause the servo when the robot's moving. No, we don't. We don't need to do that. Okay. So we should be able to drive the robot. Let's make sure that part's working.
See if this is changing the axis.
It is. And we got full speed here. Okay. We're going on a trip, and I'm going to wear this VR headset the whole time we do it. Let's go on a ride. Here, I'll make this screen a little bigger for you.
So it's going between like
Oops.
25, 24.
Smarter range.
All the way up to
There we go.
25 or 130.
I'll put this over here so you can see what I'm doing.
This value.
Ah, it's going to be so great. I'm totally looking forward to this.
13.
Here we go.
Interesting. So I'm not sure why the values aren't working. Eventually, or do get our values faster than that eventually, but for testing in 1 second is easier to read.
This is really, 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 really neat. This plant looks ginormous to me. It's the biggest plant in the world. Look at the size of this thing. It's like a tree. Whoa, it's way up there. What a big plant.
That is very weird. Okay, let's turn this off for a second. So those are soldered to the right place.
Whoa, so that's what the boardroom looks like when you're on the floor. Whoa, everything's just so massive. Oh, our camera disconnected. Might be getting some Wi-Fi interference.
Remember when we were on 7, we were getting something.
Yeah, looks like we're getting some Wi-Fi interference. Come on, robot. I was going too far away for the Wi-Fi. I should connect it to the network, and that'll work even better. Because if it's connected to the network, then our router is like up in the roof. I'll show you where our router is I'll look at it. It'll be fun. All right, let's go explore. Our router's up there someplace, up in the lights. Are the 3D printers? There's a bucket there. That's where we keep our buckets. So cool. Awesome. You know what we could do too? We don't actually have to use this headset. You can use your phone. So if you guys have like an Android phone, you can be doing virtual reality, doing what I'm doing right now. So let me show you how you do that. I'm going to make this smaller so you can see the screen again. Okay, so I'm going to back out of here. Then I'm going to close the VR client, this thing. We don't need it anymore. Okay, so let's grab a phone. We had this Android phone that we were using earlier. I'll turn it on. So this is how you can connect to your robot using the virtual reality on your phone, which is called Google Cardboard. So any Google Cardboard compatible headset will work with this. You can get the app in the Google Play App Store as well. So if you click on the question box on the virtual reality control, you scroll down. Here's a link to download. Oops, you can't see. There we go. So when you see the virtual reality robot control, you can scroll down and you'll see here where it talks about Google Cardboard. You can click on it. And you can install it on your device. So if you have an Android phone, just go right ahead. And there you go. So back to the device. I have it installed already. And here it is. There it is. So what I can do is I can type in the IP address of the computer and make sure I'm on the same network. So this device has to be connected to the same Wi-Fi network as my computer. Okay? So let's look at the computer for a second and I'll show you what I'm going to do. There's an IP address that's right here. See 192.168.0.118. That's the IP address that this server, this thing that we're running here, that's what it's listening to. Okay? So when it knows this IP address, your computer has this IP address, that's what this device, this little control, is listening to for a connection. So we'll type that IP address in here. 192.168.1.118. Oop, 0.118. 0.118. Click OK. So now we can push the robot view button. There we go. And as you can see here, we're controlling the robot.
Straight to 83 bent. Okay. Let's try the next one. Oh, I was connecting to two of them at the same time. Done. Okay. For some reason that's a short to ground.
Cool. Very, very cool. So let's drive the robot around a little bit and let's go exploring. Let's come back. Oh, we lost our Wi-Fi connection. Here, let's go back in. There we go. Hey, Bruce. Oh no. Hope I don't drive a real car like I drive robots. I'm driving into stuff. Let's look up. There I am. Hey.
That's very odd.
Let's go visit Jeremy.
So I'm gonna have to desolder some of these pins.
Jer, look up. Turn around.
Look up.
Turn around. Yeah, turn around, Jer. Say hi.
Little guy.
Oh, so great. So that's how you connect your phone to be a virtual reality headset for your robot. So you don't have to actually buy a headset. That's nice. You can get Google Cardboard or any of those like those headsets you get on Amazon for cheap. And that's about it. Too many hacking things today. Oh. I'm checking out Jeremy's hack right now. I don't know if you guys have seen it, but his Power Glove hack is coming along really well.
Just troubleshooting my flex sensors right now.
Are they hooked up to analog?
Yep.
Do they read okay?
Nope, they don't.
Jeremy broke his Power Glove.
No, I think there's just some connections.
He's hooking up the flex sensors to the fingers so that when you move the fingers, it'll read the analog voltage back so that it knows when your fingers are moved in different directions, like gripping or not. That's pretty cool.
Yeah, I think that 2 of them got shorted out.
Anything else you can say about Nito? Yeah. The LiDAR works great. You can plug a Raspberry Pi into it and read its data and plug it right into Easy Builder. And then we have working on something that's pretty neat. So right now, when you... Here, let me show you what the LiDAR looks like and how it works. Because you're going to be able to use any LiDAR. So I think I already have a project for the LiDAR, but let me see. I have another Rolly that has a LiDAR on it, so I'll be right back.
I got 2 of these pins shorted out, so it's not good. So our readings are going to be off.
Okay. So this is the LiDAR that we were testing with. This is one that we released open source on the internet, but what I decided to do on the control that we have, the protocol we standardized, so any LiDAR you can buy will connect to our control. All right. So that means there's a number of them. I have behind me, there's a shelf where I have a whole bunch of them on up there. So the idea is you'll be able to go to Robot Shop or any of these other products and buy one and with an Arduino and or make your own controller. Like there's a variety of different options to be able to make this happen. But we'll get to it. You'll see it at the end of this month. So to use this, let's start a new project. Actually, we don't need to start a new project. We just close down what we have. And for the virtual reality, and we'll just go project. And there's no camera either, so we'll close down the camera. And we'll go add. And we'll get plugins. And I believe under virtual reality, this virtual reality robot, here it is here. This plugin here is the one you're going to want to install. Not virtual reality, sorry, we're doing navigation. Under navigation, Easy LiDAR Slam is the one you'd want to install. So here's the control here for it. Okay, so I already have it installed. So I'll connect to the robot first and turn this thing on. Let's connect to its Wi-Fi. And then we'll connect to the robot. And we should be able to control it, so make sure that works. Yep. And now we'll go add navigation, Easy LiDAR Slam. Here it is here. And we will connect to it. Let's see. Connect. I think this version, maybe this version's changed. Or it's not plugged in. Let me check that. Oh, this LiDAR is not even plugged in. Okay. Let me get a cable for it. I need a camera cable. Do you have a camera cable over there?
No, but you can grab one from E09. There's some camera cables in there. Oh, just right second row very well. You know.
Okay, so the LiDAR connects to the camera cable, and LiDAR to camera. Is this the newest the newest circuit board?
Yep.
Oh, this won't work. We haven't programmed it. Yes, I can't show you this, guys. We got to cut this out entirely. Jeremy had upgraded the circuit board just recently, which is super cool. However, doing so, we don't have any firmware on this thing to show you it work. So I just realized that. That's why this wasn't hooked up. We'll postpone this for next week's hack. Okay, and I'll get the firmware on there. So essentially how it works is you would, with this particular version, you plug it into the camera port. Another version that we have that will just be Arduino, you can plug that into the camera port as well and read the data. So it'll be pretty straightforward. Yeah, you'll have to wait, Will, unfortunately. Okay, last hack. Let's do JD controlling an in move. Or do I want to order food? I think I want to eat food. I think that's what I want to do. I think I'm done hacking robots for the night. I'll turn this off and put this robot away. I got way too many things on my desk right now. One sec.
Testing out the different, different fingers. Got too many things going on here. Clean this up a little bit. Okay. There are values, and I flex the middle finger. It'll go down to, I think it was like, when I flex it was about 400K. Sometimes it goes out of range. Maximum ohmage. Okay. So let's wait. Let's try blue again. Blue. Yeah, that's not. Pulse, 2 fingers. What about the thumb? Oh, it's the thumb. No wonder. Forgot that there was a thumb. So thumb is blue. So we'll change ring finger to thumb. Echo.
Yeah, Jeremy's on the other hack.
Yeah, black is the index.
If you place an order from Easy Robot gift card, I don't know. You'd have to ask Easy Robot. I'm pretty sure. I don't know. Like they have. I know they have distribution outlets in North America now. I'm not sure how their website's set up, so I can't unfortunately answer that question and give you the information that you want to know.
I'm gonna have to look for a second. We have this wires down here that I didn't connect. I wonder if it actually is one.
Oh, do you guys want to see something cool I was hacking recently? I was making this. This was my hack today. So last week I got an Intellivision, and I bought this Intellivision. I don't know if you know the Intellivision is a game console from 1978 or something like that. And it's like my uncle gave it to me as a hand-me-down in like 1992 or something like that, which is way too late for a 1978 game console because we were already playing, Super Nintendo and stuff. And here I am with this like Intellivision from 1978. But I have to tell you, there was a couple games on it that my grandfather and I would play that was just blew my mind. They weren't spectacular. It was just like strategy, and I don't know. One was called Utopia. Anyway, last week I took the Intellivision, I took it apart, and I put a Raspberry Pi inside of it, which is an emulator, and then I hacked it so the controllers have little Arduinos that convert their controllers into joysticks. So I was on eBay, and I came across this, and not a lot of people know what this is, but this is the keyboard for the Intellivision. What happened was, when they launched the Intellivision, and I'll show you the website here. If I type in Intellivision, you're going to see a photo where it shows the Intellivision with a computer. Here it is here. Check this out. See, it makes it look like it's a computer. The Intellivision actually just looks like this. Okay? But it has controllers on it. So it looks like this. But when they marketed it like this. And people got super excited because it had a keyboard, cassette holder, and it had like an actual keyboard. And they marketed it as a computer. Well, what ended up happening is that they didn't produce this because they were getting sued. A class action lawsuit from all the companies or the customers that purchased it, all the people at home who wanted a computer. So they ended up with a game console. So Intellivision created, last minute, this thing called the ECS, which was the Electronic Computer System. And this is what it looks like here. So this was a computer that would plug into the Intellivision and turn it into a computer. Right? But they didn't release very many of them. They only made a couple thousand, just enough to be able to get the customers off their back, so they would stop getting sued $10,000 a day, which is crazy. So I came across one of these from a collector, and the collector had no idea, but I tore it apart. So today, is Easy Robot separate than Cynthium? Yeah, Easy Robot's a totally different company. Easy Robot was acquired by a company called National Robotics Incorporated, and they focus on education. So it's a completely different initiative than we were taking, and they run as their own separate thing. They don't even run in this office. They have their own facility, their own everything. So Easy Robot's not related to Cynthium at all. Anyway, so back to my cool hack is you check it out. I put a USB port on it. So inside of here is a Arduino. I'll open it up and show you. So I did this today. And I turned this thing into this 1980 something gaming, or not gaming, video game console keyboard. Now they didn't make very many of these. Like somewhere like around 1,000 or a couple thousand they made. So it's pretty neat to imagine because this serial number is 48065, and they didn't make 48,000 of these, right? So they probably made, 8,000, and this is like 8,065, which is pretty neat to think of. And it's got its original stickers on it still, so check it out. All right, good night, Bill. So here's my hot glued Arduino micro in there, and I soldered 15 wires to this thing, and then I had to reverse engineer the schematic on here, and it was a nightmare, but man, was it ever worth it. And I'll show it to you. Let's put it back together. So I'm going to have this thing plugged into my Intellivision when I get home tomorrow. And we are going to play Intellivision games all night tomorrow night. And we have a keyboard now, so I could play some Apple Adventure games if I wanted on the emulator. So to show you this thing work, before I show you it to work, let's go back to our desktop. Let me show you what I had to do to get it to work. So, Arduino, Intellivision keyboard. All right, let's take a look at the schematic. So this is what the keyboard looked like. And what I had done is I numbered, why can't I scroll with my, there we go. Cool. So I had to number each trace. So 1 to 10, and then 11, 12, all the way to 15. This last one wasn't hooked up to anything. You can see there's no trace on it. So this was a single-sided board. But what I found most intriguing about this board is, check these out. In order to jump traces, it's like they put some sort of glue down, and then they put another trace on top of that glue. I don't know if this was done like manually. It's crazy to imagine that. And the board has no other markings other than this number down here at the bottom. So what I had to do is I had to trace each one of these and understand where they connected so I can figure out what's called a matrix, right? Because there's like 48 keys or whatever it is, and in different combinations, just keys in general, not included in combinations. And then there's 15 ports. So the next thing I did was I logged each one and I wrote it into Excel. So here's what I ended up with. So on this left side here, this is output and this is the input. So what would happen is it would strobe. So it's going to send out a signal on here and check to see if it's picked up on here. If it is, then you know the shift key is pushed. Then again, it's going to strobe again, and if it picks up something, it's going to know that something else, this key was pushed. And it's going to strobe each one, strobe this, and check all these. Then it's going to strobe this, and check all these. So the code I ended up having to write, I'll load it up here so you can see. It's pretty basic, except there's a huge amount of mapping I had to do because the data that I got off of like the switches that were on here didn't align with anything to do with ASCII. So on the Arduino I mapped the pins. So the pins are each connected. Okay. And then the next thing I did was, so it depends on if I'm in serial mode or not, or keyboard mode. And then I turned the pins into the mode they need to be in. Okay. And then I created this thing called output strobe state. So you pass in which strobe it's in between 0 and 6. There's 7 different strobe positions, right? And each strobe position is a different number that you saw. And it'll put an output low because these are all on input pull-up, which means that they won't just flakily move around. So how it knows that a button is pushed is if the value goes ground, it shorts rather than being up. So I loop through each state, change the state, and then I check to see what keys are pressed, and then I determine what keys are pressed by adding these values in hex. And then if the key is pressed, right, so if it's not 0, then what I do is I say, what strobe are we on? And I add that to the key press. So you end up with a unique hex value. And then what I had to do is do an if condition for every single hex value. Ironically, 65 was A, which is correct for ASCII. Okay, so I was kind of lucked out about that. It kind of made me laugh. I thought, oh man, this is going to be ASCII? This is going to be great. Because 65 is the letter A. Now, of course, there's no capital A. Should have been 97, but I thought this is going to be great. And then I pushed B, and then 35 showed up, and I was like, 36 showed up, and I hit B. I was like, no. So this is my big if condition mapping. There's no rhyme or reason to it, so I couldn't just make any sort of algorithm to do it. Same with the numbers. You can see 1, 130, 114. And then I did the same thing. So this else here aligns with this if shift code. So if the shift is held down, then these letters just mean capitals. And the same for the numbers. The numbers mean symbols. So that's it. The next thing I have to work on is I have to make it so that when you hold a key down, it doesn't just keep looping forever. So that'll be the next thing. I was kind of doing it with this. I said if it's the last key, then don't do the last key. But that's not going to work. So what I have to do is something like bool was key pressed. And then if key is pressed,
then we will go back to our programming screen and have a look.
how did I type that? There we go. I'm so used to having syntax completion. True. Okay, so if key pressed, was key pressed true? No, we want to do last key code, return this, because the shift key, I'm not sure how that's going to help. Anyway, was key pressed, put that up here. And then if was key is not pressed, we'll set it to false. We only want to hit it one time at a time. Yeah, they were kind of like RPG games. They were, the television had games like Utopia, which was, let me show you Utopia. Man, it was one of my favorite games. It's so funny though, because like my friends we were playing Super Nintendo, and then I'd pull out my Intellivision, Utopia, Intellivision. I'd pull out my Intellivision, and all my friends would just be like, "What is going on here?" So let's see this video here. Oh. There we go. So the idea is that you each it's 2-player, you each have your own island. So somebody on this island and someone on this island. And you have so much money at the beginning, you have $100, 100 gold bars, and you can buy things to put on your island. So this guy's buying some crops, and eventually you can buy a boat. So you just bought a boat here. You can drive your own boat around, and then these things that are in the in the ocean here, these are fish. So if you drive your boat on the fish, you can drive it around. And then he just put a factory. So over time, you end up like, I know these are hurricanes, tornadoes, and they will break and tear apart anything that is in its way. So if you can build houses, like this guy's not doing a very good job of playing the game at all. Not even. Like he bought a school and a factory and like 9,000 crops. What are you doing, buddy? One crop is for 500 people. He doesn't have 500 people. Okay, let's back out of here and check out a better version of Utopia. Cool. Here we go. Yeah, so this guy's playing a little bit smarter. So he's driving his boat around. And he's going to go get some... Nice. Get some fish. And then he's buying some crops while he's fishing. And then... he bought a house. You can barely see it up here. He's not very good at this game either. I tell you, this strategy is to start building factories. I'm an industrialist. Here's some guy actually playing it. Or not. There we go. Ooh, this guy against guy. Why are you buying so many crops, buddy? He bought a boat before anything else? What a goof. Maybe they're just figuring out how to play, because I'm going to critique them. And he bought a fort and a house. And a school and a house. Okay. Well, at least he's got a factory. Smart. Okay. He's got rebels. They're not very good at the game. So I just want to make sure that when a key is pressed, if it's held down, I'm not sure. I may have to think about this for a minute. If it's held down, I probably want it to keep repeating, right? So I'm going to want it to loop. Let me think about this for a second here. I'm not sure if it's going to handle the code for looping. So we might have to yeah, Jeremy's on the other hack. Well, I think I'm done for this hack anyway. So I think I'm going to shut it down and order some food. I think it's done for the night, guys. All right, everybody. You have a good evening, because I'm fading and I need some food because we haven't had dinner yet. It's 9:30 p.m. and Jeremy's going to plow through this thing. I would watch Jeremy's hack if you get an opportunity to, because if you check out Cynthia's website and take a look at the live hack that he's got going, he's hacking a power glove. Definitely the thing you want to do. All right, sweet dreams, guys. Take care.